All right, so today we'll continue looking at section 2.2. So yesterday we looked at 2.2 part 1, where we learned the 6 definitions of the trig functions using x and y. We learned how to find the coordinates for the quadrantal angles. And then we also learned, if you're given a coordinate, how to work with that. Okay. Today, I don't think there's going to be any problems where you're given the coordinate. You're going to have to find it. So far, just to kind of make a diagram, we've got these angles. And what are those angles called again? Quadrantal angles. And those are the only angles that we know how to find coordinates for. Colby, can you remind me, what's the coordinates for 0 degrees?
1, 0.
Yep, 1, 0. Coordinates for 90, how about Luke?
0, 1.
0, 1. 180 is negative 1, 0. And PC, how about 270?
0, negative 1.
0, negative 1. Okay, so that's the kind of coordinates we worked with yesterday. Okay, today, the diagram I just showed you a minute ago, we're going to learn about the 45, the 30, and the 60. Okay, how do we find those coordinates? And then, once you learn how to find a 30-degree angle in quadrant 1 by going over and up a certain amount, well, if you make a triangle out of that, you could do the same exact thing over here. Because what ends up happening is once you know those two values for quadrant 1, it's just a mirror image to do it in quadrant 2. So all that happens is one of the numbers becomes what?
Negative.
Negative, that's all. Or if you reflect it down here, they both become negative, okay, and so on. Right? So we're just going to focus on quadrant 1 today, but once you learn the numbers for quadrant 1, that's going to be the end of what you need to memorize for the test. You don't have to memorize anything additional for quadrants 2, 3, and 4. Okay. Okay, so as I just said, we're going to focus on finding the 6 trig functions of a 30, a 45, and a 60-degree angle. So just as a reminder, unit circle trig, we only do angles that are multiples of 30 and 45, okay? Which automatically includes multiples of 60 as well. But we only do things that are multiples of 30 and 45. If you have angles that are not multiples of 30 and 45, like let's say you tried to do 57, okay, in between 60 and 45, you wouldn't be using anything I'm teaching you right now. Unit circle trig is not used to do that. You use a calculator. And that's what we'll look at tomorrow. All right, so let's take a look at the 45, 45, 90 first. And so what we're going to do is we're going to figure out what are the coordinates for a 45-degree angle using this triangle on a unit circle. Now, once we go through all this and figure the coordinates out, we never have to figure them out again. We should just memorize what the coordinates are. Okay? But if you ever forgot them, you could go through what I'm about to show you each time, but it's kind of time-consuming if you have to do it every single time. All right, so what I've done is I've drawn my unit circle. Here's 0. Here's 90. And I tried to put 45 halfway between. Remember, what that point really means is that's where the terminal side of the angle would go right through. So if you're drawing an angle, and I'll do it in a different color, that's the terminal side, going right through the mark on the circle for 45 degrees. And there's your initial side. That's what I mean. That's a 45-degree angle. Okay, what we're going to do is make a triangle out of that just by drawing a line straight down from that point to the x-axis. So just go like that. Okay, I know that's a 90 because I said I was drawing the line perpendicular to the x-axis. And I know that's a 45 because that's the angle between the x-axis and the terminal side. It was measured to be a 45. But how come the other angle has to be a 45? How do I know that? Yeah, go ahead, Alan.
There's only 180 degrees in a triangle.
Right, there's only 180 degrees, so if you add up 90 and 45, that's 135. That means 45 for the final angle. So what I've done is I've just taken this triangle and drawn it bigger over here, so I've got some space to work with it. Right, so my goal is to figure out how long is the side that I just labeled x, and what is the height of the triangle, okay, which is y. So that's like my y value. Now, in this particular problem, how is the base and the height, how are they going to compare?
They're the same.
They're the same. So really, if I want to label this diagram, I don't need to use two different letters. Okay? Just use the same letter. You could call it X and X, or A and A, or whatever you want to call it. But whatever you call the base, the height is exactly the same. What kind of triangle is that if you have two sides the same?
Right.
This one is a right triangle, but in general, if you just have two sides the same, begins with an I. Isosceles. Yeah. So this is a right isosceles triangle. So two sides the same, two angles the same. Now, in order to work with this, I have to know one of the sides. But I do. How long is the hypotenuse? 1. How come the hypotenuse is 1? Yeah.
Because the hypotenuse is the radius, and the radius of a unit circle is 1.
Yeah, exactly what he just said. The hypotenuse is the radius, right there. And we're on a unit circle. And yesterday we defined a unit circle as having a radius of 1. So now we know that side. So now we can figure out x. We can solve for x if we can find an equation that relates all the sides in a right triangle. Is there any formula that we can use that gives us a connection between all the sides in a right triangle?
Pythagorean Theorem?
Yeah,
Pythagorean Theorem?
yeah, good job, the Pythagorean Theorem. So if we know, as long as you're only missing one thing, and we're missing x, you can use the Pythagorean Theorem to solve that. All right, so let's set that up with what we have and see what we get. So Justin, could you plug in the three things that we have into the Pythagorean Theorem and tell me what the equation would be?
I don't remember what it is.
You're not sure?
No.
Anyone help him out? And tell me, just in general, how do you write the Pythagorean Theorem? What's the formula? Yep.
A squared plus b squared plus c squared.
All right, now we don't have any A, B's, and C's there, so you're just gonna have to tell me what's A and what's B.
X and y. Y.
Right, those are like the X and Y. Do you remember what those sides are called in a triangle?
The ones that are the same.
In this one they are, yeah. But there's a name for them. Yep,
They're legs.
they're the legs. Yep. And C is the
What?
hypotenuse. So you can use any letters you want, and in here we're not using the letters we normally use. But as long as you set it up as leg squared plus leg squared equals hypotenuse squared. All right, so Justin, do you think now you could tell me what the formula would be filling in what we have?
X squared.
Yep.
Plus x squared.
Yep.
Equals 1 squared.
Perfect. X squared plus x squared equals 1 squared. Add these up. x squared plus x squared. You have two of them. At this point, we can just do 1 squared and get 1. Two things I have left to do. I got to get rid of the 2, and I got to get rid of squaring. So let's start with the 2. Ben, how would I move that 2 to the other side?
Divide.
Yep, divide by
2.
2. Yep, divide by 2. All right, so now we get x squared equals a half. And Sean, I want to get x, so how do I get rid of squaring?
Square root.
You take the square root. So x is the square root of a half. And now when you square root a fraction, you square root the top and you square root the bottom separate. That's how you do it. All right, so part of that we can simplify. Kyle, what's the square root of 1? 1. The only problem is we just don't want to leave that root in the bottom. So once we fix it, then we know what x equals, which means we know our base and we know our height. So then we have the coordinate. How about Brianna? What would be my last step here to fix that square root of 2 in the bottom?
You multiply by the square root of 2 on the top and bottom.
Yep, multiply by square root of 2 on the top and bottom. In the top, you get root 2. In the bottom, you get the square root of 4, which is 2. Okay. So now we know in an isosceles triangle that's in a unit circle, the x value is square root 2 over 2. And that's used as the base and the height. So we're starting from here, which is that point right there, and we're going right and up until we get to that point. So we're going right, and then we're going up until we get to that point. Okay. So from that point, how far did we go to the right?
Square root of 2 over 2.
Square root of 2 over 2. So that's how far right. And then from here, how far up?
Same thing.
Same thing. Square root of 2 over 2. And there's your coordinate for a 45-degree angle. That's always the coordinate. That never changes. So my advice now is just memorize it. Root 2 over 2, root 2 over 2. Always that number. Does anyone remember seeing that coordinate yesterday? Yeah. It was one. I think it was one of the examples I gave you, and I said, I bet someone can figure out what the angle is, but you don't have to know it. Well, now you know it. So anytime you have a problem about a 45-degree angle, the first step is to write down its coordinate. And then from there, you just do everything we did yesterday. Okay. Any questions on how we figured out the coordinate for 45 degrees? All right, so let's go through and find the 6 trig functions for 45 degrees. Okay, I'll start you off with the first step, and then I'm going to give people a minute to kind of try it on their own. What would be the first thing you have to do in this problem? Find the 6 trig functions of 45 degrees. Okay.
Find the x and y values of.
Yeah, you've got to get the coordinate. If you can't tell me where that angle is on the unit circle, you can't do unit circle trig. So the first step is to figure out the coordinate. And now this should just come from memory. We don't want to go through all that stuff again. How about Austin? What would be the coordinates for 45 degrees?
Root 2 over 2. And
Yep.
root 2 over 2.
Perfect. 2 over 2. 2 over 2. So now take a couple minutes and see if you can find all the trig functions. But from here, it's very, very similar. In fact, I think it's the same problem that we did yesterday. All right, so let's take a look and see what we got for our trig functions for 45 degrees. Let's start with sine. Nathan, what's the sine?
Square root of 2 over 2.
Yep, and which one did you pick, just so we know?
The y?
Yes, it's the y. In this case, if you did mix them up, you'd still be okay, but in general, you don't want to do that, because if they're different, you get it wrong. So there's my sine. About Marisha, my cosine?
Square root of 2 over 2.
Square root 2 over 2. This time it's the other one, it's the x. And now when we divide them, it's y divided by x. But y and x are the same. So what do we get for tangent 45? Sean? 1. And while we're at it, let's just do the cotangent, because that's going to be easy. Can you tell me what the cotangent is as well? 1. It's also 1. All right, so cosecant and secant, once we get one of them, we're automatically going to know the other one. How come? Because sine and cosine are the same. So this should be pretty quick from here. Emma, what's my first step to find the cosecant?
It's you, since you have 2 over square root of 2, and you flip them, so it's square root of 2 over 2.
So I'm starting with the square root of 2
Yeah.
over 2, right?
Yeah.
Yep.
And then you flip them.
And then flip it. So 2 over square root of 2. And now anyone tell me what's your final answer there once you fix that?
Square root of 2.
Just square root of 2. A lot of these numbers, because they just keep coming up so often, you might just memorize, well, every time I see 2 over root 2, when I flip it, that's what I get. If you don't, that's fine. Just multiply top and bottom by root 2 and figure it out every time. Okay, and that's it. It's just 6 trig functions for 45 degrees. It's the same example you did in the notes yesterday. Only difference, you had to know the coordinate. I didn't give it to you. Any questions on that one? All right. So now I just kind of want to take a look at this. Let's say instead of a 45-degree angle, you had a 45-degree angle over here. This part, you can just watch me do this. You don't have to put this down right now. That's 180, and that's 90. Can anyone tell me what that point would be? Yep.
Negative square root of 2 over 2, square root of 2 over 2.
All right, so that's what the coordinate would be, yes. Can you tell me what that angle would be?
45.
It's got to be between 90 and 180.
135.
135, yes. And then the next thing I was going to ask, you already answered. What is the coordinate for 135? Well, that side is still root 2 over 2. That side is still root 2 over 2. And if you're like, well, wait, well, how come? Well, that's a 45, 45, 90 triangle. It has to be. Because if you look at the difference between 135 and 90, it's a difference of 45. They're 45 degrees apart. So if it's 45 degrees to get from here to here, that means this is also 45 degrees, which means that has to be 45 degrees, because that makes a 90. Okay, just using geometry. So it's the same triangle, it's just mirror imaged into a different quadrant, and it's exactly what Ryan just said about the coordinate. This one becomes negative, the other one stays positive, and you could go through and do all the stuff we just did. That's what we're going to look at tomorrow. But if you understand the idea of just making one number a negative, that's all that tomorrow is going to be. Okay, I'm just showing that because I know there's a couple people that aren't going to be here, so just kind of previewing what's going to happen. Okay. All right, 30, 60, 90. So let's look at how we could get the coordinates for a 30-degree angle. So here's 0, here's 90, doesn't have to be exact, but 30 shouldn't be in the middle. That's 45. 30 should be 1/3 of the way up the circle. 1/3 of the way towards 90. So what I've just drawn in red, that's a 30-degree angle. Terminal side goes right through that black dot. Okay, I'm going to do the same thing I did last time. What shape am I going to create out of those two rays?
Triangle.
Yep, I'm going to make a triangle, and I'm going to draw a line straight down from the point perpendicular to the x-axis. This angle at the bottom is going to be a 30, and then this angle at the top has to be a 60, and I think, I don't know, it was Jamaica or somebody said it earlier, it's because all the angles have to add to 180. So what we're working with this time is a 30, 60, 90 right triangle. I've drawn the same thing over there a little bit bigger, just so I have some room to write some stuff in. Okay, so now let's look at the triangle. Is there any side in that 30, 60, 90 triangle that I already know the length of?
Yeah.
Yeah, which side?
The initial side, right?
So the initial, like the side that's down here?
Yeah, what are you asking?
I want to know if there's, I know the length of any side in that triangle, and you said initial. What would it be?
Oh, 1, right?
Not quite. This doesn't go quite to the edge. It stops right there. If it went all the way to the edge of the circle, it would be 1. But you're kind of on the right track with
Oh,
a
so
1.
the terminal would be 1?
The terminal side of that angle would be 1, yep. Because that's, the terminal side is the hypotenuse. And what's the terminal, or the radius? The radius is 1 unit long. Okay. All right. Now, can I do the same trick I did last time? Can I call the base and the height the same thing? No. If I called them the same thing, I'd get exactly the same answer I just got in the last problem. So they're different this time. So just, again, watch this for a second. If I label them x and y, again, I would just watch for a second before you write it. The problem with doing it that way is now I have two variables. Well, I can't plug that into the Pythagorean theorem if I have two different letters. I can only use the Pythagorean theorem with one letter. Okay, so labeling them x and y isn't quite going to work. So what I'm going to do is I'm going to give you a hint at what you need to do, and it's kind of it's like a visual trick. I'm going to take and first group all that together, and I'm going to make a copy of that. Okay. Any thoughts what I'm going to do with that copy? You have to be a little creative. Suggestion, I'm going to, yep, Tanner?
Make two sides into a rectangle?
Okay, yeah, some people have mentioned that before, kind of, like if I were to flip it, I think what you're getting at is something like, and I need to flip it again, I think. You know, you could make a rectangle out of it. What would you do with that?
I have no idea. It's a rectangle now.
It's a rectangle. Yes, it is. It is a rectangle. Because we have 4 right angles and 2 sides, opposite sides that are congruent and parallels, all kinds of things you could use from geometry. It's a rectangle. Unfortunately, making it into a rectangle doesn't quite help, but you are on the right track with making it into something. Yep.
If you take it like that, you just stack it on top of the other one, but, you know, turn on that angle, a 30-degree angle.
All right, can you tell me again, how do you want to stack it together?
Like, you basically take the one to the right,
Yep.
and just drop it on the one to the left.
All right,
If you could get the computer to do that.
like that?
Like on top.
Up above it?
And then you have to angle the left side of the top triangle down, like What are you counting, man?
I know what you mean. I mean,
Pushing it.
turn it.
Yeah.
Yeah. So I can achieve what you're saying by, I think, just going like this. I think. Like that?
Yeah, I guess, yeah.
That's the same thing you would have
Same
had.
And big triangle.
Yeah. All right. So now, what kind of triangle did I just make?
What with all the sides the same?
Yes, that's the key. I made one with all the sides that are the same. Someone said
All
equilateral.
the names.
Same thing. I've got a 60, 60, 60. So all the sides are the same. So 1, 1. The important thing is that whole right-hand side is now 1. So what does that mean about just this part right there? It's a half. We just figured out one of the sides in the triangle. That one has to be a half, and the bottom one has to be a half. Okay, because we've got congruent triangles, so they both have to be the same. Any questions on that? So now we don't really need the bottom triangle anymore. We could just use the top one. If you want to keep it, you can. It just looks a little less confusing if I get rid of this. And now we've got a 30, 60, 90 triangle where we know 2 out of 3 of the sides. What could I call the last side that I don't know? Sure, call it x. Now use the Pythagorean Theorem. We can now solve for x. Okay, so let's set that up. So I've got my 2 legs. X squared plus a half squared equals 1 squared. So we get x squared plus, what's 1/2 squared? Half, think of, half of a half. Half times a half. Yep, or a quarter. So you get 1/4 equals 1. We're going to subtract 1/4 to the other side. What's 1 minus a quarter?
3/4.
3/4. Okay, last step, I'm just going to copy it up because I'm running out of space there. I got to get rid of the exponent. So what do I do on both sides?
5/2.
If the 2 was in front, Nathan, like that, you would.
Oh, yeah.
But when it's up as an exponent, I heard someone else say it.
Square root.
Square root. Square root the top, square root the bottom, but this time it's going to work out nice. You're not going to end up with the square root in the bottom because you can do it out. So you get square root 3/2. And as far as memorizing numbers, these are the last 2 numbers you need to memorize. So you learned root 2/2. Now we've got root 3/2 and 1/2. Okay, so let's write our coordinate for 30 degrees. What's the x coordinate for a 30-degree angle? Yep, the bottom is root 3/2. And what about the y coordinate? A half. That's a half from here up to here. Okay, so that's your coordinate for 30 degrees. Root 3/2, comma 1/2. Now 60 would be right here. I'm going to draw the 60 right on top of the one I have right there. 60 might be a little more like that. So there's your 60-degree triangle. Does anybody notice anything about the triangle I just drew? Yeah?
Same exact thing, it's just turned differently.
Yeah. This triangle right here, and this triangle right here, they're exactly the same triangle. It's just turned and kind of flipped. So it's still a 30, 60, 90. It's just the 30 and the 60 switch places. Instead of the 60 being at the top, like it is right there, the 60 is going to move to the bottom. Instead of the 30 being at the bottom, the 30 is going to move to the top. So if the 30 and the 60 switch places, what do you think the coordinate for 60 is going to be? Yep, 1/2, comma, and go ahead, Alan? Yep, root 3 over 2. So you don't have to memorize a different coordinate or a different set of numbers. It's the same numbers. They just switch. So the question, how do you remember which one is which? How do you remember if the 1/2 comes first in the 60 or the 1/2 comes first in the 30? Well, if you draw a 30, 60, 90, somewhat reasonable. So it's clear that one side is longer than the other. What's 1/2 as a decimal? 0.5. Okay. If you take the square root of 3 and divide by 2, that's the square root of 3, divided by 2, you get about 0.866. So root 3 over 2 is bigger, a little bit. The bigger number always goes with the bigger side. Okay. In my diagram, I think it's clear. That's the bigger side, that's the short side. Short side, smaller number. Bigger side, bigger number. Okay. Bigger side is always across from the bigger angle. Smaller side is always across from the smaller angle. That's how you can remember which one goes where. So if I had a 30, the coordinate would be root 3 over 2, 1/2. If I had a 60, I would put the 60 here, draw my triangle. I look at it, I'm like, all right, bottom side to me looks pretty short. That's a 1/2. This side looks pretty tall. That's root 3 over 2. So that's how I would figure out the coordinates for 60. X is a 1/2, Y is root 3 over 2. Okay, so just try to draw it reasonably to scale, and you'll see one side shorter than the other. That side is the 1/2. Okay, so any questions on those two coordinates? So now that we know those two numbers, we don't want to have to go through and do them again. So just memorize root 3 over 2, 1/2. You don't even have to memorize which order they go in. You can just draw a picture and figure it out. All right, so let's find the 6 trig functions for pi over 6. Tanner, what's pi over 6? That's using what kind of units?
Radians.
Radians. And if we change that to degrees, what would pi over 6 be?
30.
30. So all I'm asking you for is the 6 trig functions for 30 degrees. Cassandra, if I want the 6 trig functions for 30 degrees, what do I have to know about the 30? Something I don't have that I need if I want to fill in all 6 of these formulas. Yeah, we got to have the coordinate. Okay, now in my head I'm already thinking, all right, 30, it's a 1/2 and it's a root 3 over 2. I just have to get them in the right order. If you're not sure of the order, draw a little sketch and figure it out. But can anyone tell me what the coordinate would be for the 30? Lauren?
Root 3 over 2 and 1/2.
Yep. A lot of times what I do is I don't even draw this sketch out. I picture that in my head. And I'm like, all right, 30, it would only be up a little bit on the circle, so the long side would be at the bottom. The height would be the short side. All right, so take a couple minutes and see if you can find the 6 trig functions for 30. And then we'll finish up with the 6 trig functions for 60. All right, so let's look at first finding our trig functions of 30. So we got our coordinate, okay, root 3 over 2, comma 1/2. We'll start off with sine. Jordan, could you tell me what the sine would be?
1/2.
Yep, it's just the y value, or 1/2. Cosine is just the x value, 3 over 2. And Lauren, my tangent?
I got square root of 3 over 3.
Right, when you divide them, the 2's are going to cancel, and you're going to get 1 over root 3. So I'm going to start with that, and then you would fix it to what Lauren just said, root 3 over 3. But 1 over root 3 is still handy to have, because if you flip that, that's your cotangent. Why not flip the one with the root in the bottom, and then it goes to the top? Okay. Rather than flipping root 3 over 3, throwing the root back in the bottom, and then fixing it all over again. Sam, how about my cosecant?
2.
2. And my secant? How about Pacey?
And would be, oh, not sorry, no. Be 2 square roots of 3 over 3.
Yes. Final answer would be 2 square roots of 3 over 3. Okay. Any questions on those? All right, so let's look at the 60. Let's pretend that you didn't have the coordinate for the 30, so you couldn't remember what order the root 3 over 2 and the 1/2 go in. So what I would do is draw my triangle, put my 60. And looking at that triangle, I can tell the base is the short side, and the height is the long side. So x is 1/2, y is root 3 over 2.
Can't 2 times the square root of 3 be reduced?
2 times the square root of 3?
Yep, doesn't that just become 3?
You're thinking, I think you're probably thinking of this, the square root of 3 squared. If you had the square root of 3 times the square root of 3, that would be 3. But when the 2's in front, that's all you can do. All right, so 1/2 root 3 over 2. Step 1. Now, when we go through the answers for 60, you're going to see all the same answers we just got, but in different spots. I want you to notice the different spots. So now, sine is root 3 over 2. Cosine is 1/2. And my tangent. Colby, what's my tangent here?
Root 3.
Root 3. Okay, flip them all. We get our other ones. Secant is 2. Root 3 over 2, we just flipped that one earlier. 2 root 3 over 3. Root 3, we know when we flip that, we get root 3 over 3. So, can someone name 2 trig functions where the answers switched places? Yeah.
The sine and the cosine.
Yeah, the sine and the cosine. Okay, so those 2 switched. Can someone name 2 other trig functions that switched places? Yep, Ethan?
Cosecant and secant.
Cosecant and the secant. Those switched places. And then the last 2 that switched, the tangent and the cotangent. So to get from 30 to 60, you switch what's in each of those boxes.
Can you show me how when you divide x over y for the secant and the cosecant, how you get the square root of 3 for the cot?
How you get square root of 3 for which one?
The cot for the 30 degree?
Oh, the cotangent? Yep, we'll look at that. So first, any questions on the ones that switched places? Okay. And before we look at that, look at the pattern. Just pronounce them, and you can notice it. Sine, cosine. Secant, cosecant. Tangent, cotangent. So each function switched with what they call its co-function. Tangent with cotangent, sine with cosine, secant with cosecant. What's in those 3 boxes, those are called pairs of cofunctions. There's 1, 2, 3 different pairs of cofunctions. Okay. All right, so let's just look at how we got square root of 3. Okay, so any questions on how we got 1 over the square root of 3? That part? Okay, so if it makes sense how we got that, all you have to do is take that and flip it, and that's it. So you get square root of 3 over 1, which just turns into square root of 3. And if you're like, oh wait, he didn't do x over y. I did. I just took tangent and flipped it. That is x over y. What's nice about flipping this is we've already reduced some of the stuff out of it. If you go back to the beginning and take x over y and flip it, you're going to have to cancel the 2's out again. So I just used the version that already had it canceled. And that's how we got the square root of 3. Just flip the tangent. Okay. Any other questions on that? All right. Okay, so the homework tonight is going to be a worksheet. Okay, there's 10 questions on it. Each question asks for 1 trig function per problem. The first 10 questions are on the worksheet. The last 5 are not. Okay, so you need to either copy these onto the worksheet or just look at the video and just do them out. But you need these 5 questions from the board. And also, as a reminder, I will be after school tomorrow on Wednesday because our test this week will be on Thursday.